Right, there you go. Yeah. So you think it was just yeah, it's just that fuse you popped. That's awesome. As soon as you adjusted it. That's not surprising. It probably had a little spike on the current that just was enough to push it right over the edge.
Yep. So
that's easy.
Got a 5-amp fuse.
Yeah, I should have a 5-amp fuse actually. Now where it is, that's a whole different.
I think they're in the drawer in the back.
Okay, cool. I'm going on. That's exactly where I was headed. He says they're back here. Oh, 5-amp fuse, 5-amp fuse. All right, these are not them. 5-amp fuse, 5-amp fuse. These are the biggies. 5-amp, 250 volts. I think this is what you want.
Yep. This is 5-amp, 250.
Well, no, I'm saying because I've got different sizes of glass tubes, even.
Yeah.
You know.
Yeah, I know what you mean. They always come in slightly different sizes.
All right, I think that's the right size for you. That should get you back operational.
So. Hopefully close enough.
Oh, I got to go get my kids soon.
Okay.
Voltmeter.
Is it happy?
Oh, let's see. Just a moment. There we go.
Yay!
It's 2 points. Nice.
Right.
3.6. Six. All right. Excellent.
Probably unplug this and just move it really close to you. Yeah, I think so. Okay. Let's move it nice and close to you. There you go. And you can explain as you see fit.
Yeah. So we had 3.6 there. Right. So we now have 3.6. At 3.6 and 5 on the other. course, now the other ones are all on the back.
The memory voltages are all derivative. Those voltages are good. Your memory voltages are fine unless there's an issue. You hear me? You don't need to check them.
You don't think we need to check the back plate?
No, no.
Okay.
We already know the memory's working great. The only thing that needs to really be checked is the main voltages.
Okay.
Get them dialed in.
Okay. And then the other one is basically non-adjustable, anyways.
Oh, one more time. I gotta go get my kid. Right. We don't get into
So
those.
we can't do anything with this one because it's not adjustable, anyways.
Yeah.
So
So if you've got those 3.6s happy, you're good to go.
Okay. So what else do you want me to work on?
Now get the load memory with zeros. Right. So I'll be back in like 5 minutes. I just gotta go get my kid.
Okay. Something's not happy. So 4. Oh, yeah. Zero, 3. That's 0. So that is 6. And then that should be 0. That should be 2. So it's some other program. 3. And some of the program. Structure 3. And some of the program. Yes, memory is, I don't know what's in it. It's definitely not what we want. So load memory with zeros. how this works. Okay. I'm guessing, and I'm obviously guessing completely wrong
Uh-huh.
because I'm not getting anything to work.
Uh-huh.
I can walk through memory, and that's all I've been able to figure out. But I just randomly.
Okay, well, I don't know what. Okay.
I was trying to
Never
look at
push up. Never push up. Don't push up.
Okay.
You're at memory address 0 right now.
Yeah.
Right. If you want to get back there, master clear, right? 034004.
Yeah.
Okay. So this is your first octal.
Yeah, first octal.
So this is going to be 4.
Yeah. And then it turns off.
Oh, that's not right. Something's wrong. That's wrong.
Okay. Well, that explains why. Because I remember seeing you push down, but it wasn't lasting.
What is? I've never seen that happen before in my life.
Okay.
Okay, well, let me move out of the way so other people can see what's not supposed to happen. All right. Come on. That is so strange.
That's why I was trying to push up because I figured trying to.
Well, something's gone horribly wrong. Check. You're sure the voltages are good?
Yeah, you can try them again.
It's like clear is stuck. It's like this is stuck somehow. Whoa, whoa, whoa. See, yeah, something's stuck. You see how when you step, it shouldn't be executing.
I thought it was just displaying memory.
No, it's not supposed to do that either.
Oh.
I
I have no idea what it's supposed to do or not supposed to do.
There we go. Display was stuck on. This toggle was stuck.
Okay.
So we might need to just go ahead and clean all of these switches. You know what?
Hit the deoxy.
Yeah, that might be smartest. That's what was going on. That's what's supposed to happen.
Okay, that's what I thought I saw
Yeah.
before, but it wasn't working.
Your display was stuck. So
Okay.
it just needed a toggle, and that stopped it being stuck.
All right. Well, let's try.
Do you want one of these? There's one more left.
No,
They're tea energy drinks. Tea energy.
that's okay.
Tea energy. Tea energy.
All right, so let's try again. 4. Display stuck again. Oh, there we go. Yeah, that one's. You might as well just clean that stupid switch.
Yeah, I would turn it off. Because that's just. So annoying. I have to switch my LLM. My LLM provider.
So display is 1, 2, 3, 4. That switch. Okay. So when display was stuck, is display stuck in the bottom position or the up position?
Hmm?
Was it stuck in the bottom position? Was it stuck?
Bottom.
So it was stuck as a.
Well, I don't know. It might have been stuck in the up
It
position.
was a well.
I don't think this specific switch has a difference between up and down.
Oh, okay.
I think display is special that way.
Okay. Because what I'm noticing is when I push it down, it doesn't seem to do a whole lot.
Well, I mean, it does. That displays.
No, back here in the mechanical switches.
Oh, I believe you. I'm just saying maybe it does the same thing it does in the up by like bridging or something, right? Like I'm saying, it doesn't. I don't think that switch. I don't think there's a difference between up and down. You know, so it's the same either way.
No, but I'm saying is I think that there might be maybe the problem is it's not.
It works fine. It works great. The only problem was that it got stuck there erroneously for some reason for a moment. You see what I'm saying? Mike, you're clear on that?
Yeah, but I'm just saying that what I'm seeing is that there doesn't seem to be any real movement in here.
Yeah. You might, I don't know. I'm just saying that it works. So nothing's broken. Don't fix anything because nothing's broken.
Yeah.
The only thing to do is put a little deoxit in there, if anything. You see what I'm saying?
All right. I'll try that. See if it
If
helps.
you see where the mechanism, where the surfaces are, you know.
Yeah, I can see the contacts.
Okay. Oh, Eric.
Yeah.
This blue SCSI can't go into. That blue SCSI could go into the IDMPC, couldn't it?
Well, I mean, it can
With
go,
that ISA card.
possibly.
But that Macintosh, we don't have the right cable.
So you have IE.
Right. This doesn't. I'm just you're right. But we don't have the right.
This mic can go there.
That's already got it, SCSI.
Right, but then you would have a removable
I think the one that's in there has one that's removable.
Yeah.
You have to pull forward and mount it.
Yeah, we have to make them out.
Right. I don't think that's on the right.
Finally got it.
Like quadrant? I got it.
I know this was intended for a Mac, and this looks like some kind of possible Mac bracket.
Right, but I doubt it's that bracket. You know what I mean? But it might work for the plus, or if you had the 25, the 50 to 25.
The Plus has 50 on board, I think. No,
Well, then put
no,
in
the
your
Plus.
plus.
No, the Plus doesn't.
Yeah,
Plus doesn't have internal.
right. I didn't think any.
You have to-
I didn't think any of
You
these
have
had
to route
internal.
it back to do that.
Right.
I kind of
So yeah, give it a second to boot. Well, not boot. What actually happens is that the power fail safe restores its state. Okay. That's correct. Parity error on memory address 0. That's a bug with the power fail safe. No big deal. Try putting this, enter, display. Still got a parity error. So that's worrisome. That actually might explain another error. Enter, step, enter, step, enter, step, enter, step, enter. Okay. Master clear, display, parity error. Step, display, step, display, step, display, step, display, step, display. Perfect. Those are the addresses we put into memory, right? And then display, clear, display, clear. I don't know why we're getting a consistent parity error on address 0. That's worrisome. This is definitely fully unlocked. So the way usually to fix that is to just kind of slam that address in the core and then see if memory enter display. That's just confusing that it's giving the right.
So
So that's got to be a different error. All right.
Okay, yeah. So wait a minute, because it's going to be like parity is just going to be like odd or even or whatever they're using, right?
Well, that's what I'm saying. That's
Yeah,
what's
so-
confusing is that I put in a
You put in
1,
and it's
I
still
enter,
in the enter.
I display parity error. So I put in a 2,
Yeah.
enter, display parity error. It's a
No,
null.
you would think it's got to be one or the other if it's just a step.
Enter display a null parity error. Yeah, it doesn't make any sense. So that I'll troubleshoot. I'll bet one of the volt that might be a voltage issue. But you should be able to now, assuming actually that parity error is probably going to stop you from executing. But what you would do here is 0, 3.
Yeah, I can.
Right.
I know how to load it.
We'll try loading it in and see if we can execute the load memory with 0s. That's actually a good way to reset the memory. Otherwise, what I can do is I can pull that power failsafe card.
So that's 0. So we got 0, 3, 4, 0, 0, 4. And then we want to answer. Now, when we do enter, does it automatically increment to the next?
No. Enter, step, clear.
Master
Enter
clear.
the next one.
Okay. All right. So step. A program counter showing address 1. Just to be clear, though, I did you count the step?
No, don't do that. Clear the T register. No, do display to see whether or not you properly set memory address to
Okay.
display. Oh, look, and no
It worked.
here.
Now it works.
Yeah, well, this is what happens, right? It's a fickle machine, right? So what address is this supposed to be?
This is the first instruction. Store accumulator.
034004.
Yep.
034004. Great job. Yeah, that's exactly right. So next, what you do is
You're gonna hit
step. Whoa. So it's clear.
Oh,
Yeah.
this clears the T register. when you
That
push
just
down.
clears the T register when you toggle it down.
Okay. I
So
see
that-
this right here. Clear T. Okay. Little fine print.
Right.
And then down arrow. Okay, got it.
Right.
All right,
And
so
now
now
enter
this-
and
It
enter.
says 00026.
Right.
So it's gonna be.
And then if you screw up, that's what's great.
Just-
You can just
just-
exactly right.
just-
And you're not screwing up your because when you do the master clear, you clear your program counter. You see what I'm saying?
Yeah, that was the problem.
Right,
Like,
so you were
wait a
back to
minute.
zero.
Like, wait a minute.
Back to zero.
Okay. 26. So that's 2. 6. 4. 2. And 7. So yeah, let's enter. Step. No up. 3. Those are zeros. Okay, good. We want to memory entry. Step. Address 3. 1, 1, 0, 1, 1. All zeros. The other octal digits. Memory entry.
Okay. Now
So-
just do do display.
So this is
Oh, that's the dead bulb. Okay.
the
What do you need
dead
to
the
do?
dead bulb over here.
Yeah.
Yeah, the
Press
program counter.
program counter.
Yeah.
Press program counter.
Oh, here.
Uh-huh. Okay. Pull the front plate off.
Yeah, I could see.
And replace those two dead bulbs.
All right, where's this one? So it's got to be here somewhere.
I think it's a. Oh no, it should be right in there next to you.
That's what I'm thinking.
Oh no, it's right here.
I gotta look in the wrong place. I'll never find it.
Careful, that glass breaks off. It's rough.
So we're doing 4. Let me look at one of these.
You got the little piece of heat shrink tubing on there?
No, he doesn't.
So these are like a bayonet style, right? These are bayonet bulbs.
Not sure.
Basically, yeah. Yeah, because they're friction. They hold it on through friction with the little bump on it. Yeah, I think that's what basically really fair.
Okay. It is this friction fit, isn't it?
Yeah, you just pull it out. But you want to grab the metal, not the glass. You know, you can. You see how it comes out like a.
Okay, so it was.
Yeah, just throw that. No, put this over the bowl. Right. And then you put that tool over that. You just want to make sure you're grabbing the bowl and not the socket. Put the socket on the board. Grab the bowl and not the socket. Grab. Outside of the socket. Metal outside the socket. You want to grab onto that as hard as you can. This is
Take one more look on this other one. Okay, yeah, there's a little bit of sticking out. Not a lot.
But if you just want to grab the glass solidly with that tray, that's fine. It should. I wouldn't worry too much about it. I have not broken one of these yet. Ah. And when I say one of these, I mean one of the ones in this room. Back in Texas, I broke a couple. Which is why I didn't do something work.
So I just grab it and pull out, right? Just grab it and pull out.
Yeah, just straight out. Just pull it out. Yeah.
Okay.
You have to wiggle it a little. Barely. But if you do too much, it will break the socket off. Just be careful. Don't. I say we don't need to like give it no. One rate. Mike, it might be easier if I take that. I can take that stuff out for you. Plastic.
Yeah, that probably would be.
Would that be easier?
Probably. The bulb did break.
Oh, it broke.
Yeah, I did.
Okay, let me see.
But yeah, it's hard to even see what whether I'm grabbing it or not. It's, yeah, I know the glass is open. That's probably all I got on. Are you sure that comes out without breaking it?
I've got a lot more of them.
Yeah, it's got a friction on the side of the cabinet.
Mm-hmm.
But it's,
It's so hard to remove these.
it actually took a bulb out.
You took a bulb out?
Yeah.
Oh yeah, I see it. That's how easy these are supposed to be removed most of the time here. Get this.
Oh, there it is.
What's happened is some of these have just loosened way up over time.
Yeah, we're gonna have to 3D print something to replace them.
Yeah, no, we got to replace because these things are just completely busted.
Yes.
The plastic itself has gotten to the point where
It's just so brittle. The plastic's completely brittle. Do you want this thing to just come out?
yeah, just out. We gotta get that broken socket out. I was gonna pull those nuts real quick since it's been so difficult. You see these two nuts right here?
Oh, yeah.
Yeah, you can pull those, and then it's much easier. Right.
That's how we should have done
Yeah. Just pull those.
it. Okay.
Leave the system on. I want to go ahead and get the caps good and conditioned. Let's see. Oh, hi. Yeah, we are playing with a 1960s mainframe, doing some repair here, trying to get all of the bulbs happy. So Mike is learning the system a little bit. This is an SEL 810A from 1969. So yeah, I've got about we call these the egg crate right here. Yeah, that is 1960s egg crate. This might be from the 70s. We end up having to remove it because it is so fragile, and it gets more fragile as it's exposed to heat. And those are something like, I think it's 80 something incandescent bulbs. We have a broken bulb here. There you go. So now this should come out really easy. Just back up. Just try that now. See? And then you can pull.
A little bit easy.
Yeah, and then you can pull it out the bottom. Okay.
So you're gonna 3D print something like for this?
I've got like 100 replacements, but yeah, eventually, it's fine. Here, all right. So what you do? Okay. What's up with these guys? Are they just loose? Yeah, they're just loose. What about this guy? Also just loose. So your full row here is great. Okay. So let's take a look at our B accumulator. Right. Is this one dead or? Okay, so that one might be dead. Okay. Well, just
Okay.
A accumulator. Okay, we're missing that bulb.
And that's right here. Found it. I pushed it back in.
No, don't put the old one back in.
No. Okay.
Don't put any of the old ones back in. We've got
Fell on the floor, so I thought
Right.
it might still work. Okay, this should be a good one.
so
Came from the packet, I think, not the floor.
yeah. But, this is a tool.
Okay.
If you look closely at the bulbs, you'll see a red glow on all of them.
Uh-huh.
Except like this one's clearly dead, right? So when we do, right, it looks like we have, yeah, okay, yeah, that's the one that broke. Okay, let me see what I can do there. Just yeah. They constantly have a low current through them. Okay, let me go ahead and turn the system off. This is the broken one. I don't want to short it. All to hell. Because these bulbs 99.999% of the time fail open, luckily. So,
You kind of get the bulb out.
yeah, it glass broke.
Oh.
Oh, thanks, Mike. Yeah, I've got a lot of glass coming into yeah, there's still a lot of glass there. Okay, there we go. I'm on the socket, not on the
bulb, not the base, not the socket.
right. Shit. Come on. Yeah, it doesn't want to come. But now that it's broken, I can just get in there with a pair of pliers.
Yeah, as I was going to say, let's just get a needle, a really tiny needle. I've got that in the trunk. Do you want me to? I got the really tiny ones.
There's one
We
here.
got one right here.
No,
yeah.
There's one here.
That should grab it. Do you want to do here? I'll just grab it with this. It'll be easy because it's so large.
All right.
Let me get this glass into here while I'm still. We need to come in here with a broom. Yeah, this ought to grab it real good. What is up with this guy? You see that?
Yeah.
What is up with that? Okay, well, we'll get there in a second. Come on.
So I'm thinking we need the smaller one.
Oh no, I've got it. The problem is that it's really in there. I almost want to put there it goes. See how it's rotating the entire base?
Mm-hmm.
There it goes.
So it was just so stubborn it was never going to come out without a huge chunk.
Yeah. Well, no, what you do is you just put a little spray on there. You put a little deoxit
Oh, okay. That'll.
and then rotate it. Yeah, you deox it, wait a second, rotate it,
Okay.
and then you can get it out there. All right, so that's out.
All right. So let's get a new
Yeah,
one. For
get a
him.
new one. Make sure it's a new one. No, don't just. We've got literally hundreds of them.
They fell out of the box.
Okay, well, put them back. Put them back in the box, and then you can take them out of the box fresh. You know what I mean? Because otherwise, they will get mixed up with the old ones, and then you're going insane trying to figure out which ones are old and which ones are new. There you go. All right, let me go ahead and get over here. You
All
can
right,
turn
got
your
it.
power back on.
Got
now
the
that you
new one in
broken
there.
one out. Let's see if that works. Just wait a second for it to come all the way up. There it is. And then do the same deal you always do, which is boom, boom, boom,
So all of them on.
boom, 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 boom. See, and that's what I'm worried about, is that this guy might be just nail busted. I saw it do a little bit too much rotation. That's the one we just tried to replace, right? Did you try to replace this one too?
I didn't mess with anything else. I think that one got damaged. A couple of them got damaged when they were pulling out the separator,
Right.
the white plastic.
Right. All right. Well, what's next is just so this is the one we just tried to replace, right?
Yeah.
That's not great. That's not what I want to see at all. Come on, baby.
So we should take these two out.
No, leave this one. This one should come out, and this one, yeah, these two. This one needs to be replaced. So let's try putting a new one in there. All right. No. Then the other thing I'll do is sit there and take a known good bulb, right? See, exactly. That's what I'm saying. Like you can't,
So, yeah,
you
just give me
can't
the
make
other
any
bad ones.
assumptions here. Okay.
So you give me the bad ones you got.
Right.
I'll toss them.
See how this one's
Or you got
stuck.
them in your pocket? Or
These bayonets are really no. I threw them away. I put them. In, I throw them away as soon as.
Where's the?
Here's this one.
Okay, that's gonna. So we can throw it away.
Yeah. Got to get them thrown away. Otherwise, they will get mixed up. Like all of these seem bad or something. I don't know what's going on with this set. The ones that I'm pulling out of here, right? But they could have been mixed up because this one looks brown slightly. So who knows? I'm just going to take this whole set. That's why they can't leave the package until you put it in the machine. You know, as soon as they fall out. Okay. Well, no. Let me try one more thing here, right? Because that's just suspicious that many are. Let's use the wrong voltage. That's also possible, all right? So these both. Let me just pull all the ones that are dead right now. That come easy. That one's not coming easy. That one's about to break. That's the one we just replaced. This one should come easy. That one came easy. This one's on, but yeah, you see that red right there? You can see the bulb is warm.
Yeah.
That means that bulb is actually working. That's a problem with the circuit. So that's not great.
So these are dead?
Yeah, those are all bad. These three. Okay, yeah. These three. I'm going to need the tool for those. Where's the, there it is. Little heat shrink tubing. And this one is like bent in a weird way. I don't even know what's going on with that. So that's not great. Rotate till you can kind of see the metal, then grab the nail out of it. There you go. Easy peasy lemon squeezy. Just like that. I wish this camera did a better job of zooming in. So yeah, this one's warm but off, so we'll leave that for now. Yeah, I'm halfway tempted to go around these bulbs that are bad and put a little deoxit just down the barrels, the empty barrels. You know what I mean? I'm just staring at it, waiting to see if it wiggles or not. You know? Did you see that? Yeah, that right there. See how it wiggled right there? So now I know I'm good. Now I know I'm gonna get it. That's the wiggle. Wiggle, get that wiggle. Come on, baby. Come to me. You know, I'm actually going to put a little bit of deoxit on these guys.
That's the other one.
That's
It's right
the
there.
fader one. The other
It's
one.
right
is-
there.
Okay. Yeah, you see how this one glows so bright?
Yeah.
It's actually kind of
It's
suspicious.
just, yeah, it might be just.
I've got a foam tool I can use. Okay. This is the other one now. That's it, right? And then this one I don't know about, but it looks dead. See, what's going to happen is as we run it, more and more of these are going to die until we replace them all. That's why I'm like, just get them out, get it replaced. Because it's the fate of all of them very soon.
So these are mostly the originals from back when.
Oh God, no! I mean,
Sorry.
these are the ones that ended up in the machine at the end of its lifespan.
Yeah,
you know,
okay, that's
Random. Oh yeah, these are the ones that were definitely in store. None of them have been replaced.
So these are very old. And
These
they
are all
have-
very old.
they
Oh
might
yeah.
have hundreds of hours on them already, for all we know.
Oh yeah. Oh yeah. And yeah, these all look kind of sus. I know these are good.
Right.
So, except for this one. That's all right. So let me just put this in one of the empty sockets to see. So that's a good bulb.
Yeah.
That's a great bulb right there.
There you go. I see.
Right. So I can just go, that's my test bulb. Right. And I'm going to set that test bulb right here on this paper so we know which bulbs are test bulb. And then we're going to go back to here. And I put a little bit of that deoxit on there with just the tiniest little bit of foam. Here, take these off. So, get my tool again. And my tool. My tool and my tool. This is the one I was working on a little bit here. Actually, it was the one next to it that I was working on. That's all right. Slide this over it. Heat shrink. The ideal is I really want all of them that are right on the verge of death to die right now when I am here replacing them and not later when I don't want to. You know? There it is. And then once it's loose in the barrel, it's best to grab it with your fingers.
So do you like bad bulb?
Yeah, bad bulb.
Okay.
this one's loose or not. That is not loose at all. Grab it with the tool. Rotate the tool so we can see where the barrel versus the socket is. There we go. Grab the shit out of it. Come on, baby. There we go. Another one, thank you. All right, how many more dead ones do we have to pull? This one right here. I definitely deoxided all of that one.
There.
That one's not dead.
Oh, that's right. It's
That's
glowing
that weird one, right?
glowing faintly.
Well, no, glowing faintly is normal. That's what we want to see.
That just means it's turned off. Probably.
That means that, yeah, that means that circuit is suspect. It's probably something in the circuit itself rather than the bulb. But we can still replace it. It's just, yeah, not dead. There we go. Thank you. That actually helps so much. You have no idea. You can tell how much like instinct I built up around dead bulbs. I'm like, they are poison because I've picked back. They're all tiny little bulbs. You know, they're all over the place. I can't tell a good bulb from a bad bulb, right?
Yeah, and the
They're
filaments.
tiny.
The thing is, the filaments, even when they're basically spent, they look good.
Mhm.
You just look up at it. You just look at it in the light. The filament's still there.
Well, I'm just going to go ahead and pull these four while I'm at it. Right? I might as well. Because it makes more sense to pull every bulb
I
that
think-
could be
I think we
suspect.
pulled all the bad ones, right? Except for it was just that one. It's like
Right, well, no, that suspect one. I'm just going to
Suspect.
pull, like I said. I think it's fine, but it makes more sense to pull it than to not. Right? Because this is RTL. The entire front panel's RTL logic. It's not TTL. So it acts very differently. And I don't understand how the front panel circuit works exactly.
But this the different pile. The push to the pile.
No. It goes to the same dead pile.
Okay.
It doesn't matter. Like that bulb has been in this front panel for at least 20 years, you know?
Okay.
So, in a garage. Oh no, this one actually was in a house, but it, still.
That was the parody era.
Mm-hmm.
So that was working.
It was working. I'm going to replace it because the parity is really important. Like I said, I'm replacing all the bulbs that are not currently on. Right? Because I either don't know the state. Like getting that parity bulb back on without an actual parity error to test with is very hard. Like there's a procedure to do it actually to induce a parity error to test that bulb. It's in the manual. But we're almost done. Just one more, and then we can replace all of these. You know what I mean? Easy peasy, lemon squeezy. Because those boxes, that box I just pulled that bulb out of, those have all been perfect. Zero issues with any of those. There you go. All right. So now we take these guys. All right. Actually, let me take my test bulb. This is my test bulb. And I was curious about this guy right here. Right? Yeah, faint glow. So that's the circuit, not the bulb. Circuit, not the bulb. Yep. Like I said, all the ones in these little boxes have been perfect. You know. So. Those are the ones I start with until I'm out.
Oh yeah, you know what? It is very faint when you.
Yeah, I know. Yeah,
Very
that's
faint.
why I said circuit, but not the bulb, because
Yeah,
I can
you
see it.
that faint little glow.
Right, that
Whereas
bulb-
before it wasn't even glowing.
Right, exactly. Yeah.
So it was a combination of a bad bulb and
And the
bad
circuit. Well, probably the circuit got damaged when the circuit got damaged just now. So we'll have to go in and repair that. We'll have to figure out what happened. See, but now at least I know these have good bulbs, even though I haven't gone through the procedure of debugging the entire. And like it's a whole thing. You have to go through a procedure to get these bulbs lit, and it's in the manual, right? But you see how these two are glowing extra bright?
Yep.
Yeah, that's the same fault that they're both experiencing. And it's a sync. Like I said, it's RTL, resistor transistor, not transistor transistor.
Yep.
So that's a particular fault with the RTL logic. So that'll be the next thing to troubleshoot, right? But all you have to do here now is 0, 3, 4, 0, 0, 4, enter, step. Well, you already put in 2, 6, right? Yeah, 2, 6, step, 3, 3, step, right? So now I should just be able to hit, let's see, zero.
Okay, so
3,
yeah, so program
4,
counter is all
0,
0, so we can see the actual.
Well, now what we do is single cycle one. So memory address 1, 0, 3, 4, 0, 0, 4. That's what's about to be executed. That's so that you can see that's what's in the instruction counter. So it passes through the transfer register. This is what I'm saying. Like transfer register is used. That's what was used to transfer from the core to the instruction counter. It passed through the transfer register.
You mean the instruction register?
Yeah, instruction register. So next, if I single cycle, right?
No. Program counter incremented 1.
The instruction is 0, 0, 0, 2, 6. 2 6s in the transfer register. Right, that's IBS instruction. Oh, no. What is IBS? Hold on 1 second. Here, let me just. Okay, so now we have a result in our B accumulator. IBS. Okay, so B is B accumulator. So it should be 33, which is a NOP. Okay, so it jumped the NOP. In the 33 is the NOP, no instruction. And now branch unconditional to branch unconditional -3. So what should have happened is it stored A with a 0, increment B, and skip. Oh, that's what that is. Increment B and skip. So yeah, and there's the 1 in B. And now it's at branch unconditional 3. So single cycle should bring us back to here. Right?
So yeah, good. So we're now at address 1, not 0.
0, 3, 4, 0, 0, 4. Yeah, this looks perfect. 0, 3, 4, 0, 0, 4. Okay. We're in unlocked. Okay. Single cycle, 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 single cycle. Yeah, okay. Store A is staying 0, B is accumulating, STA should be storing.
Store it.
Yeah. So that should be. This is working as a single cycle it, right? Right. Right. And if it works correctly, if I go master clear, display, step 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 display. Right. So STA, let me go look up the manual entry for STA. Because that should be storing, that should be all nulls. It should have overwritten its own.
Yeah, that's what I was wondering.
It was supposed to overwrite itself. So,
Let's. Let's listen here too.
Whoa, 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 whoa. Good job, 73. Thanks.
Pretty even.
Well, I wouldn't do that until we put the new milk crate. Yeah, crate. Right.
Okay, let's
So
just get this back into it's easier to a little bit easier to figure out.
well, without the egg crate, it's gonna be
Blur a bit.
yeah, it's gonna be too blurry to use without the egg crate. So, oh, I hate this thing sometimes. It's nice to have so many of them though. So for this guy, oh, there it went. You see that? It just went ahead and worked. See? It ran. Yeah, it ran right there. That was it. That was great.
So now we would be displaying, right? So we're going to go to.
You can run it again if you want, right? But now everything should work. Now if I do this, enter, display, happy. Okay. So now you can enter the full bootstrap, right? But I need to move the tell type over onto the correct buster. But yeah, these two bright ones are where we have a broken trace on the back. So what we're going to want to do is they're either on the front or the back that a trace has broken. So shit. Okay. It's probably the front because of the way the stress is applied. No. Okay. Yeah. So that one's fine. So hard. Okay. So it's okay. We're gonna need Eric. All right.
So what are we trying to do now?
Figure out those faults. I figure Eric might actually be able to figure it out. Well, I don't think it's a today type of thing. Yeah. I don't think it's a today type of thing. Because yeah, it's gonna be rough. I don't know if it could be a number of things, right? What we can do is put in another one of these guys, but properly trimmed. Yeah, that probably would help a little bit there. Here's another one. All right. So that's just how they come out. Look at this one. Isn't that nasty?
So you're saying this flashing here should have been.
No. I'm saying maybe we could try that. Like,
Yeah, because it looks like on this original one, the flash at the edge was trimmed, but not on this one. Yeah, they definitely trimmed it on the original. Probably because it was easier to get in and out.
all right.
Okay, so now we gotta loosen this.
So we've got these for when we're ready for it. But no, yeah, take that back off, and then that way we can show Eric the issue at least. You know. Yeah, exactly. That's kind of what I'm thinking is for you to sleep on it.
So do you want me to install the should I install the that white separator?
What?
Do you want that white egg crate separator stuff installed?
No. It would just be in the way right now.
All right. Okay, then I'll just leave this cover on.
Right. Okay. Well, no, take that off. It makes it without it on, it's easier to access. Just leave it like it was sitting over on the table, you know?
All right.
You see what I'm saying?
All right. We will put the... All right. Ready for start.
Have you had any luck with that ID zip drive?
No, because the handle is shorted. So that's why we took a picture of it, find my-
You verified that's the issue.
It's 0.7 here short, it's pretty short, and that's right across the cap, so.
Did you see if you have the barrel for this guy, by any chance? It's got it's just a simple.
Yeah, well, we have
Not exactly.
power supply.
Yeah, that's what I'm talking about.
Didn't I give you all the? You have all the adapters are here, none of them are.
Yeah, I think so. I think that's a specific laptop that we do actually have. We should be able to just fire that thing up.
Yeah, this is the right one.
That's what I thought. It looks super weird, but it's a standard weird.
Right.
So I'm not seeing any evidence of broken traces. I don't see any broken traces.
Yeah. We're gonna have to like get in there.
I don't see any broken traces.
Yeah, I don't know if there are any. I'm saying that's most likely because I've seen this exact thing occur when too much stress was put on the socket.
Okay.
So that's the only thing that makes sense for mechanical stress to cause something like that to fail is usually a broken trace of some type or something cracked in the socket base or something. So yeah, this happened on the old machine and I was actually never able to fix it. It was dead forever. Actually, it was that forever. So I'm excited about Eric taking a look at it because he's smarter than me. And tenacious.
All right, let's look at the schematic.
Yeah. The control panel schematic is in that SEL 810A drawings manual.
Yeah. Yeah, there's manuals under this computer. So that's the drawing of the board. So we're looking at presumably, it might be Q12 maybe? No, maybe Q13. Probably 13. Yeah, 13.
Whoa.
There, schematic, full schematic for the diagram for the control panel.
Hi. Okay. And what are we fixing? It is an SEL 810A, which is a mainframe from the 1960s. In the 1970s, it would be called a mini computer, but in the 60s, it was a mainframe. As you can see right here, it actually says mainframe shutdown, which is why we're pedantic about it. And that is what we are fixing. So Mike Kennedy is sitting here and just learning the schematic here for the front panel because two of the bulbs are being problematic. Okay, take it away, Mike.
They're stuck off. I never turn on right now. This could take some time. All right. Let's try checking the logic levels. See what we're getting. So they should all be lit, and therefore they should all have the same output. 18 volts on the other side. Okay, so the bulb is, looks like it has 18 volts on one side and zero point 0.1 on the other. So basically, again, 0.1 on the low side, high side, 18 volts. Oh, so our first bad bulb has 13 volts on the low side and 18 volts on the high side. And the next one should be good. 0.2 on the low, 18 on the high. Next one, 0.1, 2, something like that on the low. High is 18. And here's our other bad one, 13 on the low side. So it's not ground, it's again 13 volts. And 18 on the high. Good bulb, 0.17 on the low, 18 on the high. Yeah. So this is not mechanical. This is definitely electrical. This is definitely electrical. This is not mechanical. 13 volts on the low side of the bulb. Turn on all the bulbs.
Okay, so a bulb that's a normal bulb that is off.
What's that?
It's RTL, not TTL. It's back.
Okay, so bulbs that are supposed to be up. So we got 14 on one. Point one on the other. On the high side. 0.1 on the other. Of course, that's not even supposed to be on. Yeah, it is out. Let's see. Let's make sure we got the right row. One off. Straight get to the next row. Got a wire bundle in my way. Okay. So this seems to be what we've got. The the outputs that are supposed to be off have about 14 to 15 volts, something like that. And that includes the ones that are turned off right now. Those two that should be on but are off. So the bulb is getting the wrong signal. It's being told to be off.
Yeah, you see how it's miners and all the other ones that are off?
Yeah, but that's probably because there's a damaged transistor and it's outputting the wrong value. It's outputting the wrong value, and it just needs to be replaced. It's slightly off, but not quite. You know, it's 14 instead of 15.
Okay, well, how do you think on the schematic, when you look at it?
I like this.
Don't confuse the computer.
I
Elliot, careful, buddy. No, go. No, hey, buddy, go. Go to the living room.
I'm giving you back your breath.
No, not on screen. Okay, go. So your mom is outside.
This is the output. So this must be the data. So this is coming out. So transistor here is 0.7. Data here, 0.7. Here. So, 4.6. So, this is 18, it's 15, so then we have to turn it off. So this is the output, it's 15. This is the ground. So this must be data and 2. Let's get a little more light. Yeah, I've seen some weird things on those bad lines. So basically what we've got here,
Here you go, bud.
okay, so here's what we got. So this is a transistor that I'm pointing to right there for bit 15. Keep in mind this is the low bit, they're counting backwards. They did that back in the 60s. So this right here is the socket for the bulb. So you could see right here, we've got 18 volts. That's the power to go to the light bulb. And then this other terminal here, this is at 0.1 volts. That's basically the output of the transistor, which is right there. And what that's saying is I want you to turn on because it's giving it basically the full 18 volts. And it's probably an 18-volt light bulb. And over here, this is the ground terminal for the transistor, and then here's the data terminal. So, this is what's going to turn it on and off. So to turn the light bulb on, you give it 0.7 volts, basically a ground. That then tells it to switch to not turn on, to be switched off, so that this ground terminal is not hooked up to here. Because here we've got, I'm sorry, it probably is transmitting it. The ground from here and ground to slightly higher than ground. Anyway, so that's indicating, turn the light bulb on. So key is this input right here, 0.7 volts, indicates turn the light bulb on. So we go over to this one, which also works. We get, I'm sorry, no, the other one that works is underneath this wire assembly, 0.7. So we go to the third one, which does not work. It's outputting 4.3 volts to the transistor. It should be outputting close to ground, close to zero. So we move over another transistor. It's being given 0.7 again. Move over a transistor. We're getting 0.7. Go to the next transistor, which I recall is bad. Yep, 4.6 volts.
Okay.
Now, there's a control. We're also looking at some of these because these other two rows, they're all turned off. All these other rows are turned off. So when we look at those, so here we got the 18. That's the power. And we can see that to truly turn off the bulb, it outputs to the terminal. One side's got 18, that's power. And the other
off, it puts 15.
It puts 15.
Like breeze through it to keep it warm.
Yeah, it just has a few volts going through, not enough to actually light it up.
Right.
Where these other two,
it does light it. Just barely.
Just the tiniest.
And that's so it can flicker on quickly. If it turned all the way off, it couldn't. It wouldn't turn on.
So these other ones, the reason why they're glowing more is because they're not getting ground, so they're not going all the way off. I'm sorry, not going all the way on. But they are getting a pretty good voltage. So that's so the signal going to this board is defective, or at least going to that transistor. To the transistor that controls the bulb is probably fine. It's just getting bad data from upstream. So that's the next one to check. Oh, the kitty's there. How the heck do we trace this back?
If you have a suspicion, I would turn it off and then go back to the schematic to identify a plan of attack.
Yeah, I'm just trying to figure out where does it go next.
Well, that's what I'm saying. The schematic, I would look for where you want to find on the board from the schematic.
I need younger eyes. Let's see.
Use your phone.
Oh, that's in the car. I think might be an 84. So trace it back to 84. Yeah, that's going to be the resistor. MC789P. All right, I think what we need next is a pinout for. Let's see. gonna do is I'm gonna top power down. I'm gonna do a couple traces. I'm gonna trace a few of these connections. Yeah. Make sure I got the right chip.
Okay, which chip do you need?
MC789. Okay. So we've got 1, 2, 3.
You said MC789, right?
Yep. Yep. MC789.
Oh, I might have found something. Motorola RTL integrated circuit. There it is.
I'm gonna need.
All right, yeah, come take a look.
Yeah.
Which case is it? Case 93?
Package P. It's gonna be P.
Oh,
It's P suffix.
oh, okay. That's a different chip. That I believe it's the same, but yeah, that's. Fairchild.
It's definitely Motorola.
Yeah. MC789P. This is the MRTL data book. Okay, good. So this is definitely the MC789P hex inverter.
All right, let's. I need to get a toolbox.
Okay.
Okay.
We did a whole lot of message prep.
All right. Let's see. 1, 2, 3. Let's see. Wait. 1, 2, 3. Okay, confirmed. We got the right resistor. All right, so that's pin 3 of 786.
And I've got that schematic up, Mike.
Okay, just about ready for it. All right, so it's pin 8. Did I see on the schematic? Yep. So the other side of it should be pin 7, which goes to circuit 30. Whatever the heck that is. And I guess 30 goes to
sure I have my phone, but.
You want to pop up and hang for a second, Dana? You gotta run.
All right. No, I can do that. Let me make sure I have my phone, and then I'll do that. Yeah, I'll just meet you up there.
Hey, Mike, I'm gonna open the back door and just leave it open because it's such a nice day
Okay.
to air out, you know?
Yeah.
And here, move this so people can see what you're up to a little bit. Huh? Let me. Here, just take a look at the camera, at the screen. Oh, there's Mike. Let's
So
see.
yeah, it's one. So the signal traced to this chip and then this chip. So it's also going to 7, 8, 6. Do you have 9 open on your screen?
Hmm?
You have 9 loaded up on your monitor?
Yeah.
Okay. Not seeing it. All right, so it outputs. Sounds right. Eight, 2, 7. Yep, confirmed. So let's check. Page down. Yep. Page up. All right. 8, 6. So that's a big, huge NOR gate. Let's see. Let us see. What do we have? One, 2, 3. Pin 3. Pin 3 of the NOR gate. Pin 3, it's an input. All right, this is strange. Let's wire 83 and wire 87. Yeah, 83, 84, 87. So 83 is not even used. It's just empty. 87's a little jumper.
You said you're looking for a black bag, because you know where it is? That's it, right? What about these bins?
I'm gonna go through.
That'd be cool.
That's my cable.
Yeah, because you're gonna be down, you're gonna be there anyway. Oh, yeah, that's right. Don't worry about that. Yeah, don't forget to hold it. Later, thanks so much. All right.
So this is kind of strange. Oh, I see. Uh-huh.
All right, Mike.
Okay, this is what I figured out. It's this the signal we need to trace back to. It turns out those are just inputs to these two chips,
Uh-huh.
so they're not the outputs.
Right.
So it's not those two chips. Those are the only connections on the board where that goes to, except for this purple one here and this orange one here, which go into the wire harness somewhere.
Uh-huh.
Don't know where yet. That's got to find the other end.
Well, I'm gonna cut off the stream
Okay.
because we're wrapping up here. But thank you everyone for watching, and hope you have a great day. That's 2.5 hours of stream right there.